Good morning, all you Sioux High Earth Science students. This is Mr. McLeod again. Welcome to our next podcast on mass extinctions and what geological events are theorized to have been involved in those extinctions. Today we will focus our attention mainly on what happened to the dinosaurs, what made them go extinct, and what geological evidence is there for these theories. So get your notes out and something to write with, and let's mass extinct some stuff. Okay, so we aren't getting chased around by any dinosaurs today, right? But we know they were once the dominant species on our planet. So, what happened to them? There are many theories about what may have happened to the dinos. Well, since nobody was there, we got to rely on hard evidence in order to build a case for any of these theories. So let's look at the most popular theory, and the one in which the evidence continues to mount each year. Okay, so these terms should look semi-familiar from our previous podcasts. So first, let's get this slide in your notes, and make sure to note something called the KT extinctions with a bold or colored line like is shown here. So I want you to copy this entire thing into your notes, and make sure you bold or color or whatever a line here and label it as KT extinctions. We'll talk in more detail about that very soon in this podcast. So get that in your notes right now. Now write that 65 million years ago, the Earth experienced a global mass extinction event, meaning that this is when the dinosaurs disappeared. Also write that this particular extinction defines the boundary between the Cretaceous and Tertiary periods that you see here. This is abbreviated the KT boundary, Cretaceous and Tertiary. Don't know why they use K? Don't really care. But Cretaceous is abbreviated with a K, so KT boundary right here, the boundary between the Tertiary and Cretaceous periods. Now also on a broader scale, the boundary between the Mesozoic and Cenozoic eras, like is shown here in this slide, we're also going to talk about. Now, the cause of the KT extinctions is one of the great mysteries in science, and scientists have proposed many kinds of theories to account for it. Write in your notes that these theories range from asteroid or comet impacts, volcanism, sea level changes, supernova explosions, and on and on. But there's four theories that have been proposed. So what exactly is a mass extinction? Write in your notes that a mass extinction is an episode in evolutionary history where more than 50% of all known living species at that time went extinct in a short period of time. Now, what we mean by a short period of time is less than 2 million years or so. So a mass extinction is where more than 50% of all known species at that time went extinct in a short period of time, meaning less than 2 million years or so. Now, 2 million years may seem like a long time to we humans, but considering the universe was created 13.7 billion years ago, 2 million years is just really a snap of fingers in time. Okay, so write in your notes that the most current geological evidence suggests that there have been 5 major mass extinctions over the first 4.567 billion years of the Earth's short life. 5 major mass extinctions. Now, we're going to try and touch on the ones leading up to the dinosaur extinction first. So, Here you see the KT extinction. Here's our bold line right here. The KT extinction. Cretaceous Tertiary, sorry, right here. Here's the KT extinction line associated with the dinosaurs. And you can also see that there were 4 mass extinctions that came before them. So here's where the dinosaurs disappeared, and 1, 2, 3, 4 other mass extinctions. So make sure you have that in your notes. Okay, also write in your notes that the Permian-Triassic extinction, the Permian-Triassic extinction, you see it right here, the Permian-Triassic extinction occurred 2.52 billion years ago, and that life on Earth was nearly wiped out, all of it. In fact, an estimated 90% of all species living at the time were extinguished. Now, also write that trilobites, you see a trilobite fossil right here. Trilobite is spelled Trilobite. Trilobites were the dominant marine organisms and were completely wiped out. And again, you see a picture of them right here. So 90% of all living things wiped out during the Permian-Triassic extinction about 2.52 billion years ago. Now let's talk a little bit about the fossil record. Write in your notes that contrary to popular belief, the fossil record is not perfect. In fact, there are many gaps that geologists are still working to try and fill every day. Now, because of this fact, the fossil record faces some challenges in terms of accuracy. Write in your notes that the first of those challenges is called time resolution. Time resolution, resolution. Now, time resolution means that the fossil record gets worse with increasing age, meaning that there's a gradual decline of dinosaur fossil numbers and their quality. Also write in your notes that the second challenge is called falsifiability. Falsifiability, which is sad but true. Falsifiability means that many hypotheses about dinosaur extinctions sound quite convincing and might even be correct, but, as you know, are not really science if they can't be tested, and falsified if untrue. Okay, so let's get some wrong hypotheses that have been tested regarding the extinction of the dinosaurs. First one, dinosaurs got so darn big that they crushed themselves. So write that in your notes. No, that didn't happen. But it was a hypothesis that was tried to be tested. Okay, the second one that tried to be tested is that somehow mammals outcompeted the dinosaurs. Write that down. Now that hardly seems likely either now, does it? Remember, mammals, really small compared to dinosaurs, lots of T-Rexes and other things that eat dinosaurs. Hard to believe that they would have outcompeted us. Okay, theory number 3 that was tested is that mammals ate all of the dinosaur eggs. Well, that seems to have been scrambled, doesn't it? But someone proposed that theory. By the way, scrambled. See what I did there? And then the last of these far-fetched theories we want you to get in your notes is that somehow it was cosmic rays that killed the dinosaurs. That would be radiation ejected from the sun. No, not too bright, is it? Remember, at the time this was probably proposed, we didn't know anything about the ozone layer or the Van Allen radiation belts or the magnetosphere that you see here. So again, just another proposal, theory-wise, totally unproven. Okay, then let's start a more plausible or believable theory with evidence that we already know. Recall from our study of ice ages that there have been many, many global climatic changes. Write in your notes that one of these dramatic changes was when the environment changed from a warm, mild one in the Mesozoic era to a cooler and more varied one in the Cenozoic era. Now also write that during that time many organisms, both marine, meaning in the water, and terrestrial, meaning on land, many of vertebrate and invertebrate went extinct. Okay, now for some current evidence. Also write that at or near the KT boundary, remember, Cretaceous Tertiary boundary, and here you see it in the rock layers right here. You see this little dark band? This is called the Cretaceous Tertiary boundary. Now, write that at or near this KT boundary you see here, and this one's from Montana, 4 important pieces of geological evidence you need to get your notes occur there. So let's list them first. And here you see a close-up of the KT boundary layer here. Now, this dark thing is just a part of this entire layer right here. So again, this whole big band right here is the Cretaceous Tertiary layer. But we're going to focus a little bit on this dark layer right here as well. So 4 things from this layer that become evidence. And I want you to write them in your notes, and then we're going to talk more specifically about them later on in this podcast. The first is iridium, I-R-I-D-I-U-M, iridium, and we'll talk again about iridium here in a bit. Second one, shocked quartz. Shocked like shocked when you put your finger in the outlet. Quartz, Q-U-A-R-T-Z. Number 3 is tektites, T-E-K-T-I-T-E-S. And then 4th was a soot layer, S-O-O-T. A soot layer was found in many areas. Now, all these are consistent with some kind of catastrophic event, meaning something happened to the surface of the earth at that time that caused all of this strange evidence to build up in this Cretaceous Tertiary boundary or layer. So what scientists are trying to figure out is what in the world would cause all of that evidence to build up in a layer, and as you can see, it's nowhere else to be found. So that's the mystery in terms of what might have happened to the dinosaurs. So we're going to take those 4 pieces of evidence and build on them in later podcasts. So that's end of podcast part 1 for dinosaur extinctions. So take a picture of those notes, submit them to Moodle, then go grab that part 1 study guide, answer the questions, and then also submit those when you're done. So we'll see you in part 2 where we'll examine these 4 pieces of evidence and see exactly what they mean and where they may have come from. All right, see you next time. Bye.